right, hello and welcome. It's MattyAtoms, where it's all space all the time. If you're new to this channel, we do simulations, we go to museums, all different kinds of places for you guys, documentaries, space news, anything outer space, we're covering it. So make sure to stop by and hit that subscribe button. So I was able to go down to the Kennedy Space Center's visitor complex for the channel, and I recorded the entire walkthrough. I recorded inside of every building. I took the bus tour, and I was able to do a Q&A session with astronaut Jan Davis. So that was really fun. I went there on Women's Day, so it was just a real treat to have her. She's really tough, and you'll really see that come through in the way that she answers some of the questions. So I started it just a little bit into the introduction. So I'm going to do the beginning of the introduction for you. Her full name is Nancy Jan Davis. She was born on November 1st, 1953 in Cocoa Beach, Florida. She spent most of her life growing up in Huntsville, Alabama. She obtained a bachelor's degree in applied biology from the Georgia Institute of Technology. And I will let the Master of Ceremonies from the Q&A session finish the rest for me. Please enjoy this chat with an astronaut, Jan Davis.
Biology from Georgia Tech, a bachelor's in mechanical engineering from Auburn University, and master's and doctorate degrees in mechanical engineering from the University of Alabama at Huntsville. As an aerospace engineer with NASA, she worked on the Hubble Space Telescope and the Advanced X-ray Astrophysics Facility. She was selected by NASA as an astronaut in 1987. She's flown on 3 shuttle missions, STS-47 being first flight of a Japanese laboratory module in the payload bay of the orbiter, STS-60, a flight which deployed the Wake Shield facility, and on that flight she served as a robot arm operator, and STS-85, which featured the deploy of the Christmas Bonds payload. She was again the operator of the robot arm on that flight, and also the payload commander. After retirement as an astronaut, she served as an executive with NASA, both at NASA headquarters and at the Marshall Space Flight Center. And she's also the author of a book entitled Airborne, a journey that connects her father's career in flight with her own. And she's here today to answer your questions. So, ladies and gentlemen, please welcome our special guest, astronaut Jan Davis.
Happy Good morning. Well, make sure you get something to eat. If you need to get up while I'm talking, that's fine. Just go right ahead. What I thought I would do today is talk a little bit about the Space Shuttle itself. And hopefully you'll go see Atlantis today, if you haven't already, and ride the shuttle launch experience so you can launch yourself into space, right? And then I'll talk a little bit about my missions, but I will leave plenty of time for questions. So save up your questions, and I'll be happy to answer any questions that you might have about flying in space or whatever questions you have. So let's talk about the space shuttle. The shuttle consists of 3 parts, really. So this is the orbiter. So the airplane part, the part you'll see Atlantis, is called the orbiter. And the orbiter has 3 engines on the bottom. And so those engines help us to launch and get into space. That's the only time we use them. And the fuel for the 3 engines is in this tank called the external tank. So it has liquid oxygen, liquid hydrogen mixed together, makes the fuel for these 3 engines. The solid rocket boosters provide most of the thrust when we take off. So that's what gives you the big push and all the shaking and noise. Most of that comes from the solid rocket boosters filled with solid propellant. And those come off the whole stack after 2 minutes. And so they fall into the ocean. They're retrieved by boats, and then they're filled again and again with solid propellant. So we use them over and over again. And so the solid rocket boosters come off after 2 minutes. The external tank stays on for another 6.5 minutes until all the fuel is gone, and then you're in space. Only 8.5 minutes to get to space. And when you get to space, you're going 17,500 miles an hour, 5 miles a second. So you go around the Earth once every hour and a half. So 16 orbits a day, 16 times around the Earth every day that you're in space. So that's how you get to space. Once you're in space, the orbiter opens its payload bay doors. You might hear the term payload. The payload is whatever flies on the shuttle. So you might have payload in the bay, you might have experiments that are payloads, you might deploy a satellite that's a payload. So they call this the payload bay. And these are the doors that have coolant running through them to keep all of our equipment cool. As soon as we get on orbit, we open those payload bays. And the way you're oriented in space depends on your mission. You know, if you need to be pointed at some astronomy object, or in my case, on my first mission, it was a science mission. They wanted a very stable orbit. The most stable is with the tail to the Earth. You go around the Earth like that, which limits what you can see out the windows. That's the only problem with that, but it's good for the science. And when you come back home, about a half an orbit, about 45 minutes, you turn the shuttle around and you burn these little engines at the top, not the main engines, but the little ones, and that slows you down. So when you're slowed down, you turn back around, come back down through the atmosphere, do some S-turns to increase the drag, and land. So at that point, you're a glider because there are no engines on. So the pilot and commander spent a lot of time training so they can make it to the runway. It's important. So you only get one chance. So that's a little bit about the Space Shuttle. My first mission was in 1992. As you heard, was the first mission with a Japanese astronaut. And so we had a large module in the back of the payload bay. It's about the size of a school bus. And we had many experiments, material science experiments, because we can make new materials in space you can't make on the ground, and life sciences, because you want to understand your own body, how it reacts with no gravity. And so we also took some animals. We took some animals, some fish, some frogs, different things to see how they react without gravity. So those are the kinds of experiments we do. And we had many experiments. We had a whole module full of experiments, and I spent a lot of time in Japan training. So that was on Endeavour, and it was an 8-day mission in 92. My second mission, you see the Russian flag, because it was the first time we had a Russian cosmonaut fly on the space shuttle. So that was a really big deal in 1994 because the Soviet Union had just collapsed. So it was our first foray into cooperating with the Russians on the shuttle program. And so on that flight, we had a smaller module. It was called the Space Hab. And this smaller module gave us more room for more experiments, mostly material science experiments. And so that was great to have more science. Also on that flight, I operated the Canadian arm. And if you go to Atlantis, you'll see the Canadian arm coming out of the payload bay. And we had a scientific satellite about as big as your table that grew crystals, very thin crystals in space. And so I was the arm operator on that flight. So that was in 94, and it was another 8-day mission on Discovery. And then my third mission was in 1997, again on Discovery. And on this mission, we had all kinds of stuff. So we put it all on our patch. We had a lot of astronomy payloads looking at the sun, looking at the Hale-Bopp comet. We had some telescopes on board to look at those things. Jupiter, just a lot of astronomy. We also had a Japanese arm. And this Japanese arm was being tested to use it on the International Space Station. So that meant I went back to Japan, which was great, and operated this arm as a test flight for International Space Station. I also operated the Canadian arm again to deploy and retrieve a German satellite. So the German satellite was designed to look at levels of ozone around the world, and they were validating their computer models to make sure they could predict ozone. So I deployed and retrieved that satellite on that mission. So that was a busy mission. I was a payload commander, which meant I was in charge of the mission, whatever robotics, experiments, crew training, crew assignments, what the scientists needed. So the payload commander pretty much took care of everything but flying the space shuttle, which of course the flying commander did. So that was a 12-day mission, very busy mission. The shuttle at that time only could fly up to 14 days or so before people now on the International Space Station could stay up months at a time. But in those days, before space station, and I didn't fly on the space station, we were only flying a couple of weeks on the space shuttle. So we were getting ready for space station on that flight. We were doing a lot of robotics to get ready and test some things for International Space Station, which has been up there now with people over 20 years. People have been on the International Space Station 24/7, 24 hours a day, 7 days a week for over 20 years. And it's truly international, 22 countries involved. So it's still a great laboratory. We have 7 astronauts up there now. Or 4 astronauts, 3 cosmonauts. Okay, so that's just a quick summary of flying on the shuttle and my missions, and I'll be happy to answer any questions you have.
Yeah, if you have a question, feel free to go ahead and raise your hand. We'll bring the microphone to you.
First question.
Right out of the gate, right over here.
Is it easier to be an astronaut with autism or not?
Is it easy to be an astronaut?
With autism or not?
With autism.
Oh, okay. I don't know. I really don't know. I don't know how that would affect you being an astronaut or not. I really don't know.
Okay, let's take a question right over here.
So, I was just wondering what it's like mentally for an astronaut when a mission is delayed, like, recently with the hydrogen repressurization, when you're kind of all geared up and ready to go. What's that like mentally when you, do you kind of prepare yourself knowing that there will probably be delays, or?
Well, I was fortunate. All 3 of mine were on time.
Yeah.
The first minute of the first window. So I don't really know. However, from talking with people when that happens, because it happens quite often. I mean, the shuttle or Artemis space is complex, and launch commit criteria are pretty stringent. You don't want to break any rules when you launch. And so it is discouraging once you get in the shuttle and get strapped in, and for whatever reason, if you have to come out of the shuttle, that is discouraging. But it kind of goes with the job, and so people know that might happen, and it's when it happens 4 or 5 times that it really gets discouraging. But 2 or 3 times, that's kind of usually the run of the course. That's usually what happens. So as far as Artemis 2 goes, they've been waiting a really long time, and so what happens if your flight is delayed like that, you go back to Houston and you get in the simulator again to make sure your training is up to date and your proficiency is up to date. You get to go back home to your families, because when you're you're in quarantine 2 weeks before the flight. And so the way it worked out for Artemis 2 was they were in quarantine for a long time, and then when it was obvious they weren't going to launch, they were able to come out of quarantine. So, you get to be with your families, which is good. And so now they're waiting and getting proficiency training, and hopefully they'll launch in April.
Yeah, I suppose the only way to really console yourself through a scrub is to remember that it's being done for your safety.
That's true.
Question right here.
What would happen if there wasn't a space shuttle?
If there wasn't a space shuttle, well, we don't have a space shuttle flying anymore. So we had shuttles that flew into space, and now they're in museums. Now you can go see one today that flew into space, Atlantis. But we don't fly space shuttles into space anymore. So we have to come up with a different way to get to space. So we have different rockets now that can take people to space. So that's what you do when one program ends, then you start another program. And we're getting ready to send 4 astronauts around the moon. So they'll be flying around the moon. And you're about the right age to one day walk on the moon. You think you'd like to do that? No? Oh, your sister does. Okay. Well, I would like to do that.
Okay, question right here.
Could you elaborate a little bit on how you mentally prepare yourself and what the feeling is like to go into space with so much uncertainty? I mean, during the 90s, it wasn't a commercial flight, let's say, and there's so much uncertainty in space.
Well, there's still uncertainty even with the commercial flights because remember, the shuttle was commercial too. You know, this was done by United Space Alliance. This was done by what's now Northrop Grumman. This was done by Lockheed Martin. So it's still commercial. So that part really hasn't changed. But to mentally prepare yourself, you do like you do when you fly an airplane or ride in a car. You decide, you know, yeah, I could be in a crash. Something could happen. But, and there's that uncertainty, you know, when you go on a car or an airplane. But you accept that risk because you want to go somewhere. And so you accept that risk. And so, since I worked for NASA for 8 years before I became an astronaut, I felt confident that we were making it as safe as we could. Yes, there's uncertainty, but that we really do a lot of checks and balances and making sure that it's safe, not only to launch but also in the design and engineering of it. And we have made the mistakes, but there's uncertainty in anything you do. I mean, the weather of it, a lot of things. So there's really, to get back to your question, there's really no mental preparation for me anyway, because once I had accepted the risk, I was ready to go. When my mom called me the day of the Challenger accident and asked me if I still wanted to be an astronaut because I had interviewed by then, and I said, absolutely, I do. So I had accepted that risk, knowing something could happen. So it's a mental preparation of a risk-benefit trade, basically.
And a sense of humor helps get you through it too. Let's say a topical story of a nervous airline passenger before takeoff. He asked the stewardess, "How many times do airplanes crash?" And she said, "Only once."
Hi, what's the process from qualifying to be an astronaut to actually being assigned your first mission? So I just wondered how that process works.
Well, a lot of people wonder that. Actually, the hardest part of astronaut selection is the initial selection. Because when, for example, the first time I interviewed, there were 5,000 applicants and only 128 people interviewed. And from that, I think 18 in that class were selected. I was not selected in that first interview. And so passing all the physical examinations you have to take, the interviews, and all of that is the most difficult part. Once you're in the program, you will fly unless you have a medical condition. And as far as how you get assigned to a particular flight, it's a mystery. It's decided by a few people in management at Johnson Space Center, the astronaut office, the crew operations director, and they try to match your background with what's on the mission. However, mission specialists, which is what I was, which all the pilots are military pilots and people who carry out the mission, I'll call mission specialists. We're trained to do anything on the mission. So we're trained to do spacewalks, operate the arms, science. We get background training in science. And so theoretically, we could be on any mission. However, they do try to match your background with what's on the mission. So my first mission Space Lab J, since I have a biology degree and a mechanical engineering degrees, the flight was material science and life science. So that was kind of a natural. The other woman on the flight, Mae Jemison, was a medical doctor, and but the other three crew members were not scientists who operated the experiments. So they try to match rookies with senior people. So there are a lot of considerations.
Okay, question over here.
Did you see our planet, our world differently once you'd been up there? Did you feel it was more precious because of the experience you'd had?
Absolutely, yes. In a couple of ways. One, you do see that thin atmosphere and how that is all that protects us from, the vacuum of space. And so you see pollution, you see effects of people on the earth uh, in a negative way. And so it makes you appreciate what we have and how we need to take care of it. So that's one perspective. The other thing is when you go around the earth every hour and a half and you see countries and you see, you don't see borders, you see one beautiful place, one beautiful home for all of us. And it would be really nice if we could all get along, but we have the same home. It's not different countries or cities, whatever. It's all one place. And I think every astronaut comes back with that perspective. Hey, we're in this together. We're all neighbors. And so let's figure out a way to get along.
Okay, question right over here.
Our next door neighbor was a pilot on the zero-G plane,
Mhm.
and he tells us wonderful stories about that time in his life. Did you ever get to
Oh, yes.
fly on it?
What was his name?
Dexter Franklin.
Okay, I don't know him, but so what she's talking about is an aircraft. It was KC-35, 135 when I was flying, but it's an airplane that goes up 10,000 feet and then it falls 10,000 feet. Goes up 10,000 feet, falls 10,000 feet. And so when it's falling, it's in a state of free fall. You're floating like you do in space, but it's only for 20 seconds or so. So you have to, do whatever you're going to do in 20 seconds. But you do a series of parabolas, and usually 40 or so parabolas. And so some people call it the vomit comet because of that. I didn't get sick, but I'm sure he has a lot of stories.
Question right here.
What were max G's you felt going up into space?
So when you're with the solid rocket boosters, it's a constant push of 2 G's. So G's with that, and then when they come off, you're actually at 0 G, and then it accelerates because the space shuttle is accelerating, so it accelerates up to 3 G's, and then the external tank drops off, and you're in space. So 3 G's is the maximum. Not bad.
Question over here.
So you said that y'all did experiments in space. What was your favorite experiment and what was the result of that?
My favorite experiment was an experiment called protein crystal growth, which actually was on all 3 of my flights, and it's on the space station now. It's a very critical experiment for research. So your body is made up of proteins, different proteins, and sometimes we know what the cellular structure of those proteins is, but sometimes we don't. And so by taking a protein solution and growing a crystal out of that solution, we can generate a perfect crystal of that protein. And so they bring that crystal back, they make computer models out of it. It's a long process, X-ray diffraction, etc. But anyway, they make a computer model and they can see where a virus might attach to that protein. And so they can design a drug to attach there so the virus doesn't attach to the protein. So on my second flight, we were trying to grow a crystal of insulin. We didn't know what insulin looked like in 1994. And so we had 3 batches, and we grew a perfect crystal of insulin, which was a huge breakthrough for diabetes research, for understanding how insulin was absorbed. They said when the crystal was growing, that helped them understand how insulin acts in your body. So it was a big breakthrough. So that was my favorite.
Okay, question here.
My son was wondering how rigorous the training is as an astronaut, and what was your favorite and least favorite training piece?
Well, compared to the Marines, it's not that hard. Because most of the challenge is mental. There's so many different systems on the shuttle that you have to learn, that to remember all of that is impossible. And then whenever you're assigned to a flight, then you have to remember all the experiments and your training. Sure, you have procedures, but there's a certain amount you have to remember. So that was the biggest training. Physically, we all, were healthy, and it was up to us to stay healthy and stay in shape. When I say healthy, I mean you can't have any chronic diseases, which they try to screen out when you interview. Make sure you don't have a heart problem or whatever. And so most of the astronauts are pretty healthy. They don't have any chronic diseases, but you want to make sure you don't. We have had to have some people drop out of the astronaut corps because they had a health issue. So the challenge physically is not as strict or hard as some training that our military does, but the mental part was the challenging part for me. And then you ask what the most favorite, least favorite part of training. Let's see. I think I really liked robotics, operating robotics, because I felt as a mission specialist it was something I could get better and better and better at. And so I worked at that, and that's why I was able to be assigned a lot of robotics. I really enjoyed the challenge of, it's like flying an airplane almost, but you're operating an arm, and you've got to work to get that whatever you've done successfully. So that was my most favorite. The least favorite part of training, I guess, is the time it took away from your own life. I mean, you had to go to Japan or Russia or wherever they wanted you to go for training, and you had simulators run till midnight, and so it was hard. And you had jobs, you had speaking engagements, so your life was really not your own, and it's a very demanding schedule, and it's not unlike what the military go through. But I guess that was the least favorite part. Most of it was great. I love to learn, and it's a lot of learning.
One of the guys described the RMS, the robot arm operations, as 2 automobiles traveling side by side at 150 miles an hour, and you have to reach over into the other car and adjust the other guy's rear view mirror. Wasn't you?
That's cool. Given your educational experience and your 8 years at NASA before you became an astronaut, how much input did you have on design of equipment that would support your experiments, given that you established a goal? And then a second question is, why zero gravity for growing protein crystals?
Yeah, so we absolutely did. As astronauts, we're involved, not the initial design of the experiments, but certainly the crew interfaces and displays on the computer and those kinds of things. We had a lot of input into that. When I say astronauts have jobs, that's part of our job. We might get assigned to the solid rocket booster design, or an experiment design, even before we're on a crew. So we all have jobs, and that's part of the job, is providing input for the design of the experiments, or how you're going to operate something. So that's very much a part of our job. And the second part was,
Why zero gravity?
oh, zero gravity. So when you're growing a crystal out of solution, so I don't know if you ever grew sugar crystals out of water and sugar, you make a sugar crystal. It's kind of like that. However, it's zero gravity. And the reason it's better in space is because you don't have a container that would affect the size of the protein because it's just growing out of solution. And you don't have gravity to bombard something else into it. So if you see videos of crystal growth on Earth and things are always hitting it, and when it hits it, it starts a different part of the crystal growing. Whereas in space, it's just growing from that seed crystal, and it just grows and nothing hits it, nothing, it's just floating and it's not in a container. So that's why the protein crystal growth is so much better in space than on Earth. They do protein crystal growth on Earth, but they don't get the perfect crystals like we do in space.
Okay, a question right here.
I wonder how hard is it, like how physical of it when you're descending into Earth is to the shuttle.
When you're coming back to Earth, when you're in the shuttle, yeah, because you haven't felt gravity for quite a while. So it is hard, especially on your sense of balance. Your ears use gravity. The fluid in your ears use gravity for balance and determining, where your head is and what you're doing. So when you don't have gravity, you lose that sense of balance over a period of time. And so when you come back, you're a little bit disoriented, and you're a little bit off balance. So that's one thing that happens. The other thing that happens when you're in space, gravity pulls fluid in your legs and your arms. If you held your arm up forever, you lose fluid. It would come in your trunk area, the middle part of your body. And so in space, that's what happens. Some of the fluid from your legs and arms goes into the trunk area. And so when you come back to Earth, guess what? All that fluid goes back down and you're lightheaded. And so you don't have as much fluid in your head. And so you get lightheaded. So what we do to prevent that is we drink salt water. So we drink 32 ounces, which is like a big thing of Coke full of water with salt tablets, water with 8 salt tablets, and that helps the fluid stay up here, and so we don't get lightheaded or dizzy or that kind of thing.
Okay, a question here.
I wonder how it is to be an astronaut.
Do you think you would like to be an astronaut? Okay. Well, it's a lot of hard work. Do you like math and science? Okay, good.
I love it.
You love it. Great. I love math and science too. So that's important to study hard in school. So I like math and science. So for me, the learning we had to do as an astronaut was really interesting and fun. And the training was fun too, because I got to go to a bunch of different countries and I enjoyed that. But flying in space is the best part. Looking at the Earth from space is the best part. And of course, it's a lot of hard work, but it's a big reward when you get to look at the Earth from space. So it's really fun. Floating in space, that's fun.
Okay, a question here.
So I'm curious on when you first had the idea to be an astronaut, and what it took to get to that interview.
Well, when I was growing up, we didn't have women astronauts. And today is International Women's Day, by the way, I think. So all the astronauts were men in the Mercury Gemini Apollo program, so I didn't even think about it. But I grew up in Huntsville, Alabama, where we have a big NASA center, and we were testing the engines that took us to the moon. So I was greatly influenced by the space program to become an engineer, a scientist and engineer. So it wasn't until I was already out of college and working for NASA before they started selecting astronauts for the Space Shuttle program. So the first astronauts for the Space Shuttle program, specifically for the Space Shuttle program, was in 1978. 1978. And they picked 35 astronauts that would fly on the shuttle. And for the first time, that included women. And so we had 6 women in that class in 1978. Remember, I started working at NASA in 79, and They picked 2 more women in 1980, and so that's when I decided that I would do it. So I was already working for NASA, already was an engineer. Fortunately, I had the right education, to make it. And to answer the second part of your question, uh, once I decided that, I knew I needed to get my PhD. So I got back in school, graduate school, and got my master's and PhD and became a pilot. I was going to do that anyway. My father was a pilot in World War II, and I wanted to be a pilot. And scuba diver. I became a scuba diver because we we train for doing spacewalks. We train underwater because that's the closest thing to floating in space that we can simulate on Earth. And so those 3 things I did, in addition to continuing to work for NASA. And so I think the combination, is what that's why I got an interview. But didn't make it to my 3rd try. So you kids, if you have a dream and you want to do something, don't get it the first time. Just keep trying. I made it the 3rd time. Yeah.
Okay, we got a question right here.
What would you say the food in space is like?
The food was pretty good. We do carry fresh fruit like you're eating here, oranges and apples, bananas. But most of the food is freeze-dried food. So we have freeze-dried food to save space when we pack all the food away and wait, because we generate the water on board. And so you add water to the freeze-dried food. It was pretty good. My favorite was shrimp cocktail. It was kind of spicy, and spicy things taste good to me in space.
Jan, did they bring up Japanese food on your first flight? And if so, did you have any of it? What was your favorite?
Yes, we took some Japanese food with us on my first flight and some Russian food on the second flight. My favorite Japanese food, and I flew it with me on all 3 flights, I liked it so much, was curry rice. So when I was in Japan, discovered they have cooked rice that they press into a foil package. And so in space, it just took some chopsticks, broke off a little chunk of rice, and dipped it in the curry rice. It was really good.
Okay, we got the last question right here.
All right. It's obviously a lot of training that goes into being an astronaut. What's something that you could not have been prepared for on your first flight, and then how did that compare on the final flight that you?
Well, the simulators actually do a pretty good job of, training you. The motion-based simulator simulates launch, like hopefully you'll go on today, the shuttle launch experience. The arm simulators were pretty good also. And the experiment simulators were good. What you can't simulate is the lack of gravity. And so on my first flight, we had some fluid experiments you couldn't train for on the ground because, the fluid is suspended and it becomes a ball, and due to the surface tension, you can't simulate that except for 20 seconds on the KC-135. So they simulate the G profile during launch in a centrifuge. So that was, that was great. It gave me confidence that, I would be able to breathe and survive the launch. So as far as big surprises, I really didn't have any. I guess some of the sensations you see and feel, like when the solid rocket boosters come away, there's a big flash, and I wasn't expecting that. And some of the operations in space, when you have shadow or Earth views that interfere with what you're trying to do, that was kind of a surprise. But I guess the biggest surprise, and it was a good one, was how incredibly beautiful the Earth is. There's really no photography that can simulate what that looks like, what your eye can see. And so that was a very nice surprise.
Now, in 15 minutes, Jan will be over at the Universe Theater giving a formal presentation that will include slides and video and more stories about life and work in space. So we invite you to come by and see that show. She's got to go over and get ready for that show now, so regretfully, she'll not have time here for handshakes, photographs, or autographs. However, at 12 noon, Jan will be up on the second floor of the gift shop, and there she will be signing autographs. We want to take this opportunity to thank you all very much for coming by and bringing such a great question to me. And we also want to thank our special guest today, astronaut Jan Davis.
Thank you. Thank you all for being here. Thank you for coming.
Thank you.
And I'll also have my books over there. I'll be happy to sign personalized for you. It's about my father, who was a World War II B-17 pilot and POW, and me. So I hope to see you there. Thanks for coming.
And a POW.
Guys.
So there you go. I hope you really enjoyed that interview as much as I did. I thought a couple of interesting things. I thought it was really cool how there was a mixture of kind of kids asking really simple kid questions and adults asking more complex questions. I thought some of the questions from the kids were really cute. I think she did a really good job handling the autism question and just not answering it. A lot of people, when given a question that they don't know the answer to, will attempt to answer it. And I think it's a very strong trait to be able to just say, I'm not sure. And finally, I think the craziest thing was when somebody just asked her about the dangers of outer space, and she said, well, you know, you take a risk when you hop in a car or hop on an airplane. And I checked. Hopping in a car or an airplane is still orders of magnitude safer than going to outer space. So it just really says something about her guts and how tough she is that she thinks about it like that. That, hey, I want to go somewhere and I'm going to take a risk. We all take risks every day. This is a risk that I want to take. I hope you all really enjoyed this interview, and I hope it inspires some of you to become an astronaut or to become the next engineers. Have a wonderful day. I hope you learned something great. Bye.